Okay, before we draw a second building and add some architectural details to our first, let's talk about a very important rule in 1 and 2 point perspective, an important technique in 1 2-point perspective called mirroring, as in mirror. Let's take a look at this rectangle. So this might seem very obvious, but notice that the diagonals run from the top of the rectangle on the left through the center to the very bottom of the rectangle on the right. This is obvious, but this principle can be used in a number of different ways to construct regularly spaced increments. So let's say I have a second rectangle here. Let's make it roughly half the size of the first, but not terribly important. Now let's say I want to construct another rectangle that's exactly the same dimensions as this over here. How do we do that? Well, we can use a ruler, obviously, but look, we're drawing straight on right now. So this is going to apply to things that are in perspective later, in which case a ruler is completely useless. And in fact, we don't need a ruler to do this. What are we going to do? We're going to find the center of our first rectangle, like this, by making a little X, and use the center point here to find out where the middle of this line is. So the middle of this line is right here. That's going to be the center of my larger rectangle. So we know the diagonals run from the top corner through the center and come out at exactly the same place on the opposite side. They reflect each other. So the next step is to extend the bottom of the rectangle by a little bit, extend the top of the rectangle a little bit, and now we know that in a rectangle, a diagonal runs from the top corner through the center. It ends up on the same place at the opposite side. So if we run a diagonal from here to the center, where is it going to end up? At the bottom of my rectangle on the opposite side. That's how we get the same width here over here. If I want to draw another rectangle of the same size, I need to repeat the process. So I'm going to take the middle of this, extend it to my next increment, like that. Then I'm going to extend the bottom and top of my rectangle a little bit more. Like this. And like this. And again, since we know that diagonals run from the top through the center and end up at the same place on the bottom, we just repeat the process. So from the top of the second increment through the middle of my third is going to give me my fourth increment. So on and so forth. This technique is very useful for getting regular increments when they're going back in space. So obviously when you're drawing straight on, use a ruler. But when you have things that diminish back in size, like a series of telephone poles or fence posts, we're going to use this technique. So this is really important for lots of different things, doing lots of different things in 1 2-point perspective, a technique called mirroring. Let's apply it to our drawing and build a fence in front of our barn, I guess to protect the livestock. Let's draw a vertical line here. Let's place it over here like this. That's going to be our first fence post. Then we're going to have a series of fence posts going back in space this way. So the first step in building fence posts is to, where is my red pen? Here it is to draw lines from the bottom of the fence post and the top of the fence post going back to VPR. This way and this way, like this. Okay, Next step, you determine where the second fence post is. So it could be close, it could be further away. I'm going to place it right about here. Draw your second fence post, like this. And now we're going to use the technique of mirroring to figure out where our third fence post is. How do we do that? We need to find the center of our first rectangle by doing a zigzag. It's going to look like this. Then we're going to take the center and find where it is here on our second fence post. So that's going to be the second, that's going to be the center of our larger rectangle here. So we're going to need that all the way back in space because we're going to do not just the third increment, but the fourth, fifth, just going off into the distance. So find the middle of this going all the way back. All right, so now that we know where the center of the second fence post is, I'm going to do this. I'm going to run a diagonal from our first increment through the middle of our second to figure out where our third increment is. Dot, 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 dot. At this intersection, place your third fence post. Here's our third fence post, and if I want more fence posts, keep repeating the process. So from the top of our second increment through the center of our third is going to give us our fourth increment. Here's our fourth increment, and we just keep going and going and going and going. So from the top of our third increment through the middle of our fourth will give you our fifth increment. Hopefully you guys see how this works. I'm not going to continue, right? Build a whole row of fence posts. So this is a technique when you have regularly spaced intervals going back in space. Telephone poles, fence posts, I can't think of anything else. Look, markers on a road, whatever it is. This technique is used at the very most advanced levels for constructing regular shapes on one side as you have the other. So if I'm drawing a car in perspective and I need the same details on one side as I have on the other side, you can use mirroring to calculate that. So it's used at a very, very high level. We're not going to go quite that far in this class, but let's use this mirroring technique to build a center door on our barn. Well, we already have the middle. We already have this intersection. That's already done. All we need to do is draw a line through it to find the middle of our doorway. Let's just do this for right now. Okay, so the next step is to build a doorway, build half the doorway on this side. So we're going to draw a rectangle. We can make it whatever dimensions we want. We can make it a large door. We can make it a really tiny door. Let's build a large door here, so some kind of airplane hangar. And then we're going to mirror the rectangle over here onto this side. So let's figure out how tall the doorway is going to be. Then you decide how wide the doorway is here. That's something that you guys set. Like this. So here's our first rectangle, just like we had here, our first rectangle. What's the next step? We need to find the middle of this rectangle. Let's find the middle by doing a little zigzag. Okay, here's the middle. We're going to use that midpoint to find the middle of this center height, just like we were doing here. right? We're finding the middle here. Let's do that. So we're going to line up our ruler VPL, the center of our first rectangle, and finding the center point right here. Because we know that a diagonal running from the top corner through the center of our rectangle is going to end up somewhere on the bottom and give us the same width as you have here. Let's do that. Okay, this shouldn't be in black, but I want you guys to see it. Okay, do you see where this diagonal ends up? That's the back of my door. So this is just one really simple way in which the technique of mirroring is used in 1 and 2 point perspective. A centered doorway.